8 medieval water storage secrets that modern preppers desperately need. Picture a medieval monastery in 1347, right before the Black Death hits Europe. The monks at Fountains Abbey in Yorkshire are storing thousands of gallons of clean drinking water in their elaborate system of stone cisterns, lead-lined channels, and clay vessels. No electricity, no plastic, no municipal water department, just ancient engineering and materials that had been working for centuries. Fast forward to 2021. Texas freezes for a week and the entire water system collapses. Pipes burst. Treatment plants fail. 5 million people have no clean water. Modern preppers scramble to buy bottled water that's gone in hours, or they're filling bathtubs with tap water that'll go stagnant in days. Meanwhile, if those medieval monks had survived the plague, their water storage would still be perfectly drinkable 6 months later. What did they know that we forgot? Clay pot refrigeration. Let's start with something that sounds impossible. Medieval households across the Middle East and Mediterranean stored water that stayed cold, without ice, without electricity, without any power source at all. They used something called a zier pot, and the physics behind it would make your high school science teacher weep. Here's how it worked. You take 2 unglazed clay pots, one smaller than the other. Put the small one inside the big one. Fill the gap between them with wet sand. That's it. That's the entire system. The water inside the smaller pot would stay cold, sometimes dropping 20 to 30 degrees Fahrenheit below ambient temperature, in a desert, in summer. The science is called evaporative cooling, and it's the same reason you feel cold when you step out of a shower. The water in that wet sand evaporates through the porous clay. Evaporation requires energy, and that energy gets pulled from the water inside as heat. Medieval people didn't understand thermodynamics, but they understood that their water stayed cold and drinkable far longer than water in sealed containers. Your modern prepper's plastic water jug? It's sitting in your garage getting warm. UV rays are breaking down the plastic, leaching chemicals into your water. The water inside is the same temperature as the air around it. You've got maybe 6 months before that water tastes wrong, and maybe a year before you're questioning whether it's safe. The zier pot system was still working in Egyptian villages in the 1990s. A teacher named Mohammed Abba revived the design and won a Rolex award for it in 2000. He distributed 12,000 pots to Nigerian families and extended the shelf life of vegetables and water by weeks. Not with fancy technology, with 2 clay pots and sand. Here's what modern preppers miss. They're so focused on filtration systems and purification tablets that they forget storage temperature matters. Cold water doesn't just taste better, it inhibits bacterial growth. A zier pot sitting in your basement could keep your emergency water supply cold and safe far longer than any plastic container, and it requires zero maintenance beyond keeping that sand damp. Stone cisterns and mineralization. Medieval castles and monasteries didn't just store water, they improved it. The massive stone cisterns built across Europe from the 11th through 15th centuries were doing something your modern stainless steel tank can't replicate. Limestone cisterns, specifically. These weren't just holes lined with stone. They were carefully constructed chambers where water would sit for weeks or months, slowly absorbing calcium and magnesium from the limestone walls. Medieval people called this sweetening the water. They didn't know about minerals and pH balance. They just knew water from old stone cisterns tasted better and seemed healthier than fresh rainwater. Modern research backs this up completely. A 2003 study by the University of Padua analyzed water from 13th century cisterns still in use in Venice. The limestone had been naturally mineralizing the water for 700 years. The calcium carbonate content was high enough to buffer acidity and prevent pathogen growth. The water was testing cleaner than modern tap water in some districts. Compare that to your typical prepper water storage. Food-grade plastic barrels. Maybe steel drums if you're serious. Both are inert. They don't interact with the water. That sounds good until you realize that fresh rainwater or reverse osmosis filtered water is slightly acidic and has zero minerals. It's actually aggressive toward materials it contacts. It'll leach metals from pipes or containers. Medieval cistern water was self-balancing because of that limestone contact. The Viking settlement at Lonso Meadows in Newfoundland, dating to around 1000 AD, had a stone-lined water collection system. When archaeologists tested the stones, they found the same calcium carbonate buildup. Cold climate, different continent, same principle. These people understood that stone and water had a relationship. Your modern water storage? It's dead water, mineral stripped, pH unstable, just sitting there hoping nothing grows in it. You're adding chlorine or bleach to keep it safe. Medieval cisterns were doing the same job through passive mineralization, and the water came out healthier than when it went in. And here's the kicker. Those medieval cisterns are still working. The one under Edinburgh Castle has been in continuous use since the 1300s. Your plastic barrel has a recommended replacement schedule of 5 years. The chemistry isn't even comparable. Wooden barrel technology. You think medieval people just threw water in a barrel and hoped for the best? The cooperage trade was one of the most respected crafts in medieval Europe for a reason. A properly made wooden barrel could store clean water for months or even years without the water going bad. Your modern approach can't touch that timeline. The secret was in the wood selection and treatment. Coopers used specific types of oak, chestnut, or pine, depending on what they were storing. For water, white oak was king because of its tyloses. That's a botanical term for cellular structures that make the wood watertight at a microscopic level. The wood swells when wet, sealing itself. No glue, no plastic liner, just wood doing what it evolved to do. But here's what most people miss about medieval barrels. The wood wasn't just a container, it was part of the purification system. Oak contains tannins, natural antimicrobial compounds that leach into water slowly. A 2015 study from the University of Seville found that water stored in oak barrels had significantly lower bacterial counts after 30 days compared to water in glass or plastic containers. The tannins were actively suppressing microbial growth. Medieval coopers also charred the inside of water barrels lightly. They didn't fully understand activated carbon, but they knew charred wood made water taste cleaner. Modern science confirms that charcoal absorbs impurities and off flavors. Your fancy Brita filter? It's using activated charcoal. Medieval coopers were doing the same thing 800 years ago by accident. The lifespan of these barrels was ridiculous. A well-maintained water barrel could last 50 to 100 years. There are wine barrels in European cellars that are 200 years old and still perfectly functional. Compare that to your modern prepper barrel. The manufacturer tells you to rotate it every 5 years because the plastic degrades, the seals fail, and nobody trusts water that's been sitting in plastic for longer. And maintenance was simple. You kept the barrel wet so the wood stayed swollen. You scrubbed it once a year with coarse salt and hot water. That's it. No special chemicals, no replacement gaskets. The barrel aged like furniture, getting better with time as the wood seasoned. Modern preppers have completely abandoned this knowledge. They're buying 55-gallon plastic drums and treating them with bleach every 6 months, fighting a losing battle against algae and plastic breakdown. Meanwhile, you could build or buy an oak barrel, char the inside yourself, and have water storage that improves your water quality instead of degrading it. Lead-free ceramic glazing. This one's going to surprise you because medieval people get a bad rap for using lead in everything. But when it came to water storage, certain medieval potters knew exactly what they were doing, and it had nothing to do with lead. Islamic potters in Andalusia and Persia developed tin-glazed earthenware around the 9th century. The technique spread through medieval Europe by the 13th century. The glaze was made from tin oxide, silica, and other minerals but specifically excluded lead for drinking vessels. They called it Majolica in Italy and faience in France. The key advantage? It created a completely non-reactive surface that didn't leach anything into stored water. The potters understood something modern consumers often don't. Lead was cheap and made beautiful, shiny glazes, so it got used for decorative pottery. But water storage vessels? Those got the expensive tin glaze because the potters knew lead made people sick. A 1991 analysis of medieval Italian water jugs found zero lead content in vessels explicitly marked or designed for water. The crafts guilds actually had regulations about it. Compare that to modern water storage. Most preppers are using plastic, which leaches BPA, phthalates, and microplastics. Even BPA-free plastic substitutes other chemicals that we're now discovering might be worse. Glass is safe but fragile. Stainless steel is fine but expensive and conducts temperature, so your water gets hot in summer and cold in winter. Medieval tin-glazed ceramic was completely inert, maintained a stable temperature due to the mass of the clay, and lasted indefinitely if you didn't drop it. Spanish olive oil merchants were still using 15th century ceramic storage jars in the 1950s. Some were 500 years old. The glaze hadn't degraded. The clay hadn't cracked. The vessels just kept working. And here's where it gets interesting. Modern testing on these ancient vessels shows the tin glaze actually had mild antibacterial properties. The tin oxide created a surface where bacteria struggled to establish biofilms. Water stored in these containers stayed cleaner longer than in untreated clay vessels. The medieval potters were engineering microbial resistance into their products without knowing about microbes. Your modern plastic jug is designed for a 5-year lifespan, maybe 10 if you're lucky. Medieval ceramic water storage was designed to outlast the person who made it, and the chemistry made the water safer. We traded up for convenience and traded down for longevity and safety. Well house protection. Medieval communities didn't just dig wells and leave them open to the sky. They built elaborate well houses, and the design reveals an understanding of water quality that modern preppers completely ignore when they're installing hand pumps. A typical medieval well house was a stone structure built directly over the well opening, with a peaked roof, ventilation slots near the roof line, and a heavy wooden door. This wasn't just weather protection, it was temperature regulation, contamination prevention, and quality preservation all in one design. The stone walls provided thermal mass. During summer, they kept the well cool, which suppressed bacterial growth in the water. In winter, they prevented freezing. The peaked roof shed rain and snow away from the well opening. The ventilation slots prevented condensation buildup that could drip contaminated water back into the well. And the heavy door kept out animals, debris, and opportunistic poisoners during times of conflict. But the genius was in the interior design. Medieval well houses often had a raised stone rim around the actual well opening, creating a dry zone that prevented ground contamination from being tracked directly into the water. The bucket was stored on a wall hook, not on the ground. The winch or pulley system was elevated. Every element reduced the chance of surface contamination reaching the water. Archaeological excavations of medieval English villages show that wells with permanent well houses had significantly less debris and lower pathogen levels than wells with temporary covers or no protection. A 2008 study comparing medieval well sites in Northamptonshire found that protected wells maintained water quality for an average of 300 years longer before requiring decommissioning due to contamination. Modern preppers are punching a hole, installing a pitcher pump, and calling it good. No structure, no temperature control, no contamination barriers. Just a pipe sticking out of the ground that'll freeze in winter, heat in summer, and collect every piece of wind-blown debris that passes by. They've eliminated 700 years of design refinement in the name of simplicity, and the maintenance requirements highlight the difference. A medieval well house needed the roof checked every decade and the door replaced maybe once a century. Your modern pitcher pump has plastic seals that dry out, leather valves that crack, and metal components that corrode. You're replacing parts every few years. The medieval design? It's still working in villages across Europe, some of them 800 years old. The well at Caerphilly Castle in Wales has the original 13th century well house still standing and functional. 800 years. The roof's been repaired, obviously, but the stone structure is the same stone the masons cut in 1268. Your fiberglass well cap has a 20-year lifespan if you're lucky. Charcoal filtration systems. Medieval water filtration wasn't just about straining out visible particles. By the 14th century, some European monasteries and castles were running water through charcoal filtration systems that would make modern preppers jealous. The setup was brilliantly simple. Water would flow from a collection cistern through a series of chambers filled with different grades of crushed charcoal. The first chamber had coarse chunks that caught larger particles and sediment. The second had medium-grade charcoal that absorbed dissolved impurities. The third had fine charcoal powder that polished the water to clarity. The filtered water would then flow into the final storage cistern. Charcoal works because it's incredibly porous at a microscopic level. A single gram of activated charcoal has a surface area of over 500 square meters. That massive surface area absorbs organic compounds, chlorine, heavy metals, and many pathogens. Medieval monks didn't know about surface area chemistry. They just knew that water run through charcoal tasted clean and didn't make people sick. The Carthusian monastery at Clermont-Ferrand in France installed a charcoal filtration system in 1383 that was still in use in the 1790s. 400 years of continuous operation. Modern analysis of the system found 7 feet of charcoal in 3 sequential chambers, exactly as described. The monks replaced the charcoal every 25 to 30 years by flushing the chambers and refilling them. That's it. 3 centuries of maintenance summarized in one sentence. Your modern Berkey filter? It's using the exact same principle. 2 black charcoal elements that cost $160 and last for 6,000 gallons. Medieval monks were filtering thousands of gallons per year through cheaper, longer-lasting systems. They weren't manufacturing complex ceramic filter elements. They were making charcoal from hardwood, crushing it to different grades, and stacking it in stone chambers. Low tech, long lifespan, better results per dollar than almost anything modern preppers are buying. And here's what modern preppers forget. You can make charcoal. It's not complicated. You burn hardwood in a low oxygen environment until it's completely carbonized. Then you crush it. The medieval method produced effective water filtration using materials you could gather in a forest. Your modern filter requires a factory, precision manufacturing, and a supply chain. Which one is actually better for long-term survival? Ice house storage. You think ice storage was just for the rich? Medieval ice houses were common across northern Europe by the 1200s. And they were storing not just ice, but also keeping water cold and drinkable for months without any mechanical refrigeration. The design was all about insulation and drainage. You dig a pit, usually 10 to 15 feet deep, line it with stone or brick, and fill it with ice during winter. But the genius was in the structure above the pit. Thick stone walls, a thatched roof with at least a foot of thatch for insulation, minimal openings, and a drainage system at the bottom of the pit that prevented meltwater from pooling. Ice stored in these houses would last through summer and into the next winter. Records from the royal household at the Tower of London show ice being harvested in February 1249 and still present in October of the same year. 8 months. No electricity. No compressors. Just stone, thatch, and understanding how temperature and insulation work. But here's what matters for water storage. Medieval households would store containers of water inside the ice house, packed in straw or sawdust near the ice. The water would stay cold but not freeze. This extended the drinkability of stored water far beyond what was possible in ambient temperature storage. Cold water doesn't just taste better. It actively inhibits bacterial growth. Every 10-degree drop in temperature roughly doubles the time before bacterial colonies reach problematic levels. A study by the University of Helsinki analyzed medieval ice houses across Scandinavia and found that water stored at ice house temperatures, around 35–40 degrees Fahrenheit, remained bacteriologically safe for up to 6 months without any treatment. Water stored at room temperature? 2 to 3 weeks at best, before bacterial counts spiked. Modern preppers completely ignore temperature control. They're storing water in their garage, where temperatures swing from freezing to 100 degrees Fahrenheit seasonally. They're fighting algae and bacterial growth with chemicals because they've abandoned the most effective preservation method: keep it cold. Building an ice house isn't even expensive. You don't need perfect insulation. Medieval people used whatever materials they had. The ice house at Mount Vernon, built in the 1780s using medieval principles, is just a brick-lined pit with wooden doors and dirt piled on top for insulation. It still works. You could build a smaller version in a weekend with basic tools and materials, and the harvesting was sustainable. You're cutting ice from ponds and rivers during the coldest part of winter. No energy input beyond human labor. No refrigerants, no electric bills. Just taking advantage of winter's cold to preserve summer's water supply. We replaced this system with mechanical refrigeration that requires constant electricity and maintenance. That's fine when the grid's up. What's your backup plan when it's not? Rainfall collection and first flush systems. Medieval architects designed buildings that were water collection systems disguised as structures. The guttering, downspouts, and cistern connections on medieval buildings weren't afterthoughts. They were part of the original design, and they incorporated principles that modern preppers are paying hundreds of dollars to learn about today. The key innovation was the first flush diverter. Medieval builders noticed that the first water off a roof after a dry period was contaminated with dust, bird droppings, and debris. So they designed systems where the first several gallons would divert into a separate chamber or simply overflow past the cistern inlet. Only the cleaner water from sustained rainfall would actually enter the storage system. The mechanism was simple: a small holding tank with a float valve. The first flush water fills the tank, raising the float, which then redirects subsequent flow into the main cistern. Once the rain stops, the first flush tank slowly drains through a small hole, resetting the system for the next rainfall. No electricity, no moving parts beyond a float and valve, just gravity and clever design. The Alhambra Palace in Granada, built in the 14th century, has dozens of these systems still visible in the architecture. Modern testing of the cisterns shows they maintained remarkably clean water despite collecting from roof surfaces exposed to birds and dust. The first flush systems were keeping contamination out for 600 years before modern engineers invented the concept in the 1990s. Your typical modern prepper is running rain gutters straight into a barrel. No filtration, no first flush, just whatever washes off the roof going directly into storage. Then they're wondering why the water tastes weird or has visible contamination after a few weeks. They're ignoring medieval engineering that solved this exact problem 700 years ago, and the scale was impressive. The Alcazar of Segovia in Spain could store over 5,000 gallons using medieval rainfall collection. The entire structure was designed to channel water from every roof surface towards cisterns. During a 3-month siege in 1474, the defenders had enough stored water to outlast the attackers. That's not just storage. That's integrated architectural water security that modern preppers can't match without spending thousands on tanks and filtration. The beauty of these systems was redundancy. Multiple collection points, multiple storage locations, multiple filtration stages. If one part failed, the system still functioned. Modern preppers are putting all their water in one 500-gallon tank, connected to one section of gutter. Single point of failure. Medieval designs assumed things would break and planned accordingly. Conclusion. Here's what connects all these medieval water storage methods. They're passive systems that improve water quality over time instead of fighting a losing battle against degradation. The clay pots cool through evaporation. The stone cisterns mineralize. The wooden barrels filter with tannins. The ceramic glazing resists bacteria. The well houses regulate temperature. The charcoal absorbs contaminants. The ice houses preserve through cold. The collection systems filter automatically. Modern prepper water storage is the opposite. You're using inert containers that do nothing but hold water while it slowly becomes less safe to drink. You're adding chemicals to fight problems that medieval designs prevented through material selection and structural engineering. You're replacing equipment every few years because it's designed to fail, not to last. Medieval water storage assumed you couldn't just turn on a tap when things went wrong. It assumed you needed water to stay safe for months or years without intervention. It assumed you couldn't run to the store for replacement parts. These weren't romantic notions. These were survival requirements. And the solutions they developed actually worked for centuries. The technology isn't lost. You can build a Zier pot today. You can line a cistern with limestone. You can buy or make an oak barrel. You can install a charcoal filtration system. You can build an ice house. You can add first flush diversion to your gutters. The knowledge is available. What's missing is the recognition that these old solutions often perform better than their modern replacements. Modern preppers spend thousands on complex filtration systems, plastic tanks, and chemical treatments. Medieval communities stored clean water for months, using materials they could source locally and maintain indefinitely. Which approach is actually better for long-term resilience? The expensive system that requires replacement parts and expertise? Or the simple system that works through physics and chemistry that won't change regardless of supply chain disruptions? The medieval approach wasn't primitive. It was appropriate technology refined over centuries of trial, error, and survival necessity. We abandoned it not because we found something better, but because we found something more convenient when conditions were easy. Now that preppers are planning for hard times again, maybe it's worth looking at what actually worked when times were consistently hard. If you found these forgotten techniques valuable, hit the like button and subscribe to Medieval Over Modern for more discoveries about what we lost when we stopped looking backward. Drop a comment and let me know which water storage method surprised you most, or if you've actually built any of these systems yourself. Share this with anyone interested in prepping, homesteading, or just understanding why the old ways sometimes worked better than what replaced them.